So 0 and 0 are 0. 0 and 0 is 0. 0 and 1 are 0. And 1 and 1. What is 1 and 1?
1.
1. Okay. So 1 bitwise ANDed with 3 is equal to 1. And that's totally non-intuitive until you start thinking about the bits. That ANDed with that one, come up with that one. There's only one bit on and we're ANDing it against another value. Well, if this one was a 0 right there, let's do that one. Let's do A is equal to 1 and 2. So we have 0, 0, 0, 1. That's the 1. What's a 2? It's a 0, 0, what?
0, 1, 0.
Yeah, 0, 0, 1, 0. That's a 2. And we're going to OR them together. So what's a 0 or a 0? 0. What's a 0 or a 0? It's a 0. What's a 0 or 1?
1.
1. What's a 0 or 1? 1. Okay, so 1 and 2. Oops, I meant to do and. Anyways, 1 or 2 is equal to 3 because 0, 0, 1, 1 is 3. Now I want to actually do the one that I was trying to show. A is equal to 1 and 2. Same idea. 0, 0, 0, 1, 0, 0, 1, 0. We're going to AND them together. What's that going to result as?
0.
Yep, 0 in the first one. What's next?
0.
What's next?
0.
And
0.
yeah. So 1 and 2 equals 0. But 1 or 2 equals 3. And that's if you're using these. These are operators. These are bitwise operators. And you use them for manipulating the bits inside of numbers in order to see like if the leftmost bit is set or if some bit in the middle is set. And why would you do that? Well, in order to conserve space like in an internet header, a packet. They'll say something like, okay, the first 4 bits of this stream represent something. And then the next 2 bits of this represent something, and then the next 2 bits of this represent something else. And this may be like the protocol you're going to choose, you know, and this may be the priority you're going to choose. So since you have 2 bits, you have, you know, several different choices of how many, you know, what the protocol is. That would be 4 different possible choices. But if you wanted to find out whether that one bit was set, you could AND this against something that only had that bit set to 1. So if this was your data, and you ANDed it against this, if your result was 0, you would know that that bit was not set. If your result was 1, it turns out it was set. So what is 1, 0, 0 in binary, in decimal? Well, it's not a 1, it's not a 2, it's a 4. So if we did D and 4, we stored that in some result, then if A is 0, it means that that bit was not turned on. If A was 1, then it means that bit was in fact turned on. So let me Google up what a TCP packet looks like. I think I'm just totally making this up in a weird hallucination. So here we go. Come on, come on. Really? Oh yeah, I forgot. This was the hamster-powered machine. Here we go. So, TCP packet. That one looked good. So, down here we can see that I don't even know what these mean, but each one of these is an individual bit. And if your hardware wanted to determine whether this was a sync packet or an ACK packet or PSHA packet, I'm kidding, I have no idea what PSH stands for, or whatever, then you could take this data, you could AND it against a specific value, and you would extract that bit. Or if you want the last 2 bits, you would AND it against a 2-bit number. So like, suppose we have a series of bits, whatever, and we want to find out the content of the last 2 bits. Then we would AND it against something that was all zeros except for the last 2 bits. And then, after we were done with that, we would get an answer that was all zeros except for the last 2 bits, which would be whatever was up here. So again, that's AND. So we were able to inspect this and to find out what the value of the last 2 bits were. In this case, it's just 1. But if it had been 1, 1, we'd get 1, 1 down here. Or if it had been 1, 0, we'd get 1, 0 down there. You may see that as a programmer. That's why we went over that. There's one other operation which is really important, which is shift left and shift right. Say you have a 8-bit number that looks like this, and then you shift it 1 to the right. That means that all the bits go to the right. So that's shifted right once. And then you shift it right again, it looks like this. You shift it right again, you can see all the bits are marching towards their doom. Why do I call it that? Because what's going to happen to this guy once we shift it right once more? He disappears. The jokey name for that is he falls into the bit bucket. There. That's shifted right one more time, and then you shift it right one more time still, and it's completely zeroed out. Now, if I had had a 1 in that place, then I'd have to shift it 2 more times in order to completely zero it out. So you can shift your data. Why would you want to do that? Well, suppose you only were interested in these 2 bits, and you wanted it, to AND it against something that had the last 2 bits lit up. Then you could shift it. Also, you can use shifting as a form of multiplication. What if we had this number? I'm going to do 2-bit numbers now. That's a 3, right? Now I'm going to shift it to the left. It becomes like this. You see why? These bits marched 1 to the left. So what is 110? That's a 6. Are we all in agreement?
Yes.
Good, because it's correct. And then we shift it once again. What are the bits going to be when we shift it to the left again?
12.
It's going to be 1100, and then we shift it, and that turns it to a 12. So it turns out that shifting to the left is the same as doing a multiply by 2. And shifting to the right is the same as doing an integer divide by 2. So shift left is same as multiply by 2. Shift right is same as integer divide by 2. And surely you believe me about shifting right. We could prove that. What was this one? This one was a 1, 2, 4, 8, and 16. So that's a 24. So what's this one? 1, 2, 4, and 8. That's a 12. And what's this one? It's a 2 and a 4. So what's that?
3.
Yeah, you could guess even just from the pattern what's going on. And then what's that? That's a 1, and that's a 0. So, 24 divided by 2 is 12, divided by 2 is 6, divided by 2 is 3, divided by 2 rounded down is 1, divided by 2 rounded down is 0. So I'm going to fire up Visual Studio and make a new project. Make it an empty project. I'm going to call this, I guess I'll just give it the date. July 6th. So here's my Solution Explorer. I'm going to go to Source Files and I'm going to add a new item. It's going to be a C++ file, and I'm going to call this one main because it's going to have our main method in it. Excuse me, our main function in it. So let's do our usual. Now, I don't even think we need any includes in this one. So int main, yeah, we probably will need our usual one. What do we always start these off with? IO stream. And then to be safe, we usually include string as well. And then we do using namespace std. Now this one's not going to use strings or but it will use the std namespace. So what this function is going to do is it's going to print a birthday message. So we're going to call a function called birthday, and we're going to pass in somebody's name. However, that function doesn't exist, so we're getting an error. So let's go write that function. But we're going to put it in another file. So as soon as y'all are done typing, we're going to add another file to our project. And do projects as small as the ones we've done so far need to be broken up into multiple files? No. But when you're a professional programmer or you're writing, games or something, you're going to have huge amounts of code. And they have to be broken up into files in order for you to even comprehend it or to be able to pass them around to other people for, to get them to help you. Okay, so now I'm going to come over here to source file and do add new item, and we're going to call this one birthday.cpp. And this one's going to have our birthday function. Same couple includes. Include IOStream, include string, using namespace std. So birthday doesn't have to return anything, so I'm just going to declare this type void. It's not returning anything. But it does need to take a string as a parameter, which is the name of the person we're saying happy birthday to. And it's # include. I don't know what I was thinking when I did that. There we go. # include IOString, # include string. All right, let's print happy birthday to them. Happy birthday to you. Happy birthday to you. Oh, I forgot my semicolon. Semicolon goes outside the quotes, not inside it. And then, happy birthday, dear name. So, happy birthday, comma, dear, followed by their name, followed by ENDL, or quote /n, whichever you like better. And happy birthday to you. Okay, so now we're done. That's enough to, that's our function. But just because we wrote this function over here doesn't mean that main knows how to call birthday. And the problem is that main doesn't have a prototype for birthday in its mind. So it has no idea what the birthday function looks like, what kind of parameters it takes, or what it might return. So we're going to have to declare a prototype for the birthday function. Well, the prototype of a function is just its header. It's the type, it's the name, and then it's the parameter list with a semicolon at the end. So when you're done typing all that, just highlight that line and copy it. So now I'm going to blip back over to main, and I'm going to add that prototype. And it needs to go underneath the includes, like that. It's just that function header ended by a semicolon. Now, strictly speaking, it ought to be put in a header file. We'll move it to a header file in a minute, but I want to make sure that the code works first. And I forgot to put a pause, so it ran and it closed the window. Can't do that. System. Pause. And it says, happy birthday, dear Joe, happy birthday to you. So that worked. But you don't want to define that prototype in every source file that uses that birthday function. You just want to put it in one place. So we're going to cut that. I'm going to highlight that prototype, cut it. And if you're a little bit behind, that's okay. I'll come back and I'll revise these and I'll walk around and make sure we all get a chance to do it. And then I'm going to go to source files over here and do add. It's going to be a new item, but instead of being a CPP file, it's going to be a header file. And it's going to be birthday.h rather than birthday.cpp. And in that file, we put our function header. Unfortunately, it doesn't know what this string is. It's possible the whole thing will make anyways. I'm going to do a rebuild solution and see if it makes. String is undefined. Okay, it's really wanting us to have that defined. So what do we got to do? In our header file, we need to include string. So include string. It still says string is undefined. Include iostream.h. No, iostream. Are we good now? Yeah, we're good now, but main doesn't have an include for this header file. We have to go back to main and add an include for birthday now. So I'm going to go over to main. I'm going to do, underneath the string one, I'm going to do include birthday. Nope, I'm going to use quotes rather than braces. Include birthday.h. And now it'll run again. So to recap, we have three files now. Main.cpp has this code, which has got main in it, which includes a call to our custom homemade function called birthday. We also have birthday.h, which contains the prototype for the birthday function. And then we have birthday.cpp, which has the actual code for the function. And it would be reasonable to also put a # include birthday here as well. So go back to birthday.cpp and include that as well. It works without it, but include birthday.h. You may have some other definitions in that header file that this function relies upon. And so typically you include the header file for that function, for that code, both in the code itself and in where you call it. So why do we use quotes rather than the angle braces? The angle braces are used for the C++ libraries at Microsoft or Apple or whoever gives you, or the new C libraries, whatever. This searches a search path. If you put quotes around it, it opens it only if it's in this same directory. So anything you add to your source, all of your own H files, you're going to use quotes around. Alrighty. I would like for everybody to get this going. So I don't know which of these screens would be the best one to leave it on. I want to check. Got yours up and running?
I got slaughtered.
Alrighty. Oh, I went way too fast. So this is birthday.h. That's your prototype. Okay. Birthday.cpp. Excellent. Source.cpp. Excellent. I think you only had that one. So that's going to work.
In case it's along with generic.
since we have moved this definition into its own header file, we don't need it here. That can't have been it. It was.
That was cool.
Why did it list 30 pages of errors for that? Okay. Anyways, now you
Thank
got it
you.
working. It's doing this for everybody, not just you. I'm gonna just say that all. Let's go look at Redefinition again. That looks good. Look at name. That looks good. Now maybe that we have saved everything, I'm gonna do delete. Do rebuild. Just a guess. All right, guys. Something that's causing us some grief is that in my header file for birthday.h, I should have added our using namespace. So using namespace std. And what's happening is that it's working for some people and not for others, depending upon where. Not pound sign using, sorry. Depending upon where they did their include birthday. If they did it above the using namespace, it's not working. If they did it below the using namespace, it does work. Okay. So you've got yours. Awesome. Let's go. change that one to say include IO stream. And then another one that says include string. Just like normal. And then using namespace. STD. Yes. Now my look, let's give it a shot. So now take this prototype here and move to birthday.h. So just cut it. Right off that line. Yep. Now, cut it. Go to birthday.h and paste it below your music namespace. Cool. All right. Now, file save all or something. I guess there's no save all, but whatever. Yeah. Rebuild it, see what happens. So they give us an error list. Okay, those two ones. Right, go to birthday.cpp. See right there. Come in. As I said. Okay, then come under here and do include birthday.h. Once I include. Which one after this C floats around and rather than name purposes. Yes, or double quotes, I'm sorry. Quote there, quote there. There you go. Okay, cool. Perfect. You got yours running, right? Nope, okay. Entry point must be defined. Well, we have birthday, but we don't have main. You're gonna need a main as well.
Oh,
So, here's what main looks like. Got yours going?
yeah.
Cool deal. How about you?
Did back up something not for IO stream and string, that ever problems with namespace? Still,
And it still worked. The reason why is if you go back to, for example, your main. Okay, we are including IO stream and string before you do # include.
so,
If we change the order, if we did include birthday.h above those two things, it would stop working.
I'm curious then, if these two, what, birthday dot H, would they still even put here? Or
No.
since that's the same included, it would
No,
be here?
that is correct. We can move those into it. So one kind of optimization we could make, very, very, very good point, is that you don't need these # includes everywhere. If birthday.h relies upon string and IO stream and that using namespace std, you could take those guys and put them in birthday.h, which they already are. Which means that we could take them out of main, and we could take them out of birthday.cpp and just leave them inside birthday.h. And the same for that using namespace std. We could even take that out because it's part of birthday.h. Now our code looks real simple. All we have is one include and then some code underneath it. So you got main one, right? It's not going to work yet, but now we need to add birthday.h. Ew. Wait. Okay. So this is the code that goes in main. We're going to cut this stuff out. We're going to make a new file called main. Add new item. Yeah. Call it main. Go ahead and rename it. this stuff up at the top. Copy that, paste that there. Now we need birthday.h. We don't have birthday.h yet. We even need that line, but take all that stuff, come over here, source file, add new file, new item, but it's a header file. Now make this one birthday.h.
Oh, okay.
Can't include itself, but otherwise that's fine. Okay, now we can go back to here. We don't need that anymore. We don't need that anymore because all of that is inside birthday.h. Same is true for here inside of main. We don't need that and that anymore because it's inside birthday.h. So we're getting an error because it doesn't know what birthday looks like. So in birthday.h, you need to add this line, you need to add the prototype port. So add that to it. And then when you have that done, switch over to birthday.cpp. I think it is spelled string. Yeah. Good, okay. Go over to birthday.cpp and add our happy birthday code to it. That looks like that. Now when you add a new header file, sometimes you'll see that it adds, depending upon which system you're using. Visual Studio doesn't seem to be doing it. You'll see it, why am I getting an error? Do I really have an error or is it fixed? Okay. You may see it do something like this. Over in the header file, you may see this. # if in def, birthday_h, # define, birthday.h, birthday_h, and then there'll be an end if at the bottom. You don't need to add that. I'm just saying that you may see this come up. If you see this come up, it's not an error. What this means is you only need this # include in one place. If you came over here and you included some other header file, include, I don't know, party.h, and party.h also had it include for birthday.h, let's go make a party.h that all it has is that in it. So we have party.h, which has include birthday.h in it for whatever reason. And then inside of main, we are including both party.h and birthday.h, which means that there's a redundancy. I don't know if you can visualize that in your head, but party.h includes birthday.h, and now we're also including birthday.h. And in certain cases, that can cause problems if that code is included more than once. In this case, it wouldn't cause any problem, but it could. And so people do this in order to avoid the code being included more than once. The first time the code is included, birthday age is not defined, so it goes ahead and it defines it, and then it does all of that. And then the second time it's included, birthday_h is defined because of that, and so all of this is skipped. You may see that. A shortcut that a lot of more modern compilers support is something called a pragma statement. If you see that, it's the same thing, it just is much shorter. It means only include this stuff once, please. I don't care if you do # include 20 times in a row with the same file name. This code will only be included once. So this is not a bad idea at all to stick up on the top of your header files. But quite often you won't need it. quite often your code will not break because you don't have it. But it is a way of ensuring that if that header file is included in more than one place in one source code file, that it does not break your program. I'm not going to try to give you a... Yeah, I can force it to need that. Let's declare a string that's called BD message, and it's equal to happy birthday. And that's what we want to be printed out each time. And we think, oh, I'm going to put that in a header file. That would be great so that my birthday program could use that. So instead of doing cout happy birthday to you, it can do cout BD message. Like that. And that's cool. So if I want to make it, in Korean or, whatever, I can just go to one header file and change it. Sounds great, but this should give us an error. Redefinition, multiple initialization. And this is the kind of thing that can drive you absolutely crazy looking for it, because that's a pretty vague error. BD message, redefinition, multiple initiation. You double click on the error, it takes you there, and you go, I'm not defining it more than once, I'm only defining it in one place. Well, what's happening is that it is being defined in more than one place because we are including it multiple times by dint of birthday.h being included both as party.h and birthday.h. So if we go back to birthday.h and do pragma once, that should make the error go away. And if it doesn't, then we're not going to spend any more time on it. No. Still didn't work. I'm not going to fix it. But that's why, even though I failed to show that that was a fix for it, if you see pragma once, that's what that means. Pragma once means only include this code once in your source code file, even if you have multiple includes for it. And if you see that pound sign, if in def, whatever, it's trying to do the same thing. This is just a C++ way of doing it, and your code, your X code over there was doing the C way of doing it for some reason. And the rest of y'all aren't seeing that at all. Okay, so we have written code now. Let me take that out and take this out because it totally broke it. We have used a header file successfully. I wish that I could do this. I wish that I could pop open a command prompt, cd into the right directory, and then do compile. I don't remember if it's VCC or whatever, filename.cpp, and have it make the object file. And then I wish I could do link filename.obj, and it would make the object file. However, Visual Studio assumes or doesn't assume that you're going to be doing all this stuff by hand. Whereas if you have a Linux install, it's very likely that that the compiler and the linker are all part of the search path, and you can go to the command prompt and do this kind of stuff. So CPP file turns into object file by the compiler. The object file is linked to make it executable. Just kind of keep that in the back of your head so that you can spout that off and look knowledgeable, because that's what it's all about. All right, let's go to Unit 2, grab Chapter 5, download it so it's easier to view. Well, we've already been here for an hour and a half. Anybody need a break? Bathroom break? Yeah, let's chill for 5 minutes. Go to the bathroom and stuff. So we'll pick back up at 8:45. And I forgot to answer your question. I'll show how to do that, how to include it all in a while loop.
Well, I figured it out.
Oh, good. See, my negligence allowed you to bang your head on it until you got it to work. Good job.
Kept searching Google pages. Excuse me.
Mm-hmm.
Oh, this will work.
That could be why it was an exact duplicate. Just a sec. That's homework 4, right?
Right.
I'm pretty sure this one in class. I always finish all the homework in the class. About 1 hour.
I'll show you what I mean. I may have been totally wrong. Let's look. And then let's get the other one. Okay, what's weird about it is that they are identical down
Oh,
to the
okay.
the placing of the
Okay.
of the comments and stuff
So
like that.
I didn't remember. So.
So it's identical.
Oh, okay. So this one I'm going on doing this one.
So
Is that-
I don't know if y'all worked on it together or
Yes, we work on
okay.
it together.
That would explain why. If we did this one in class, then I'm gonna say okay, and I'll go ahead and give y'all good grades on it.
Okay.
But we need to make sure that in the future our homework doesn't look the
Looks
same.
the same. Okay.
All right.
So is that this one's fine for you?
Yeah, I'll
We
fix
work-
it. I'll
working
change the
together?
grade.
Okay. All right.
Okay.
Yeah, I make sure that's every homework is.
All right.
the same.
Okay. But it turns out that this is what we did most in class, and y'all worked on it together, so I'm gonna go ahead and get but in the future, you just need to make sure in class stuff is okay to work on together, but homework needs to not look the same. But I'll go ahead and
Okay, question. On this one is. I really.
probably I just have graded it.
Oh, okay. So why is that zero?
No submission.
It's pretty sure that's the last time. I see this. I didn't do this one. Yeah, not to determine this. I tell you this.
Yeah, you would have been here for that. I don't know why
Yes.
it wasn't submitted. See if you can find it. I'm pretty sure, I mean, I know you did it, so
Yeah,
look on your files and see if you can find it, and then upload it. If you can't find it, just upload a Word document saying that you can't find it, but I know you were here that day.
Yeah, I was okay. And on this one, I must have told you that. You remember this? You said you told me this. Just remind me.
Right.
Remind you to this.
Okay,
I did this one.
right,
But you.
yeah. Alrighty guys, this is going to cover some stuff that we've already talked about, so we won't have to sweat it much. Plus plus, that's called increment. It adds one to a variable. VAL plus plus is the same as val equals val plus 1. Why do that? Well, it's because in programming you add one to things so often that they made a shortcut for it. And that's all it is just a shortcut. You can use the plus plus before it or after it. Now this is actually important, and we hadn't discussed this. So, put away your Facebook. I'm kidding. But if you do this, A is equal to 10, and then you do B is equal to A plus plus, and then you output A followed by a space, followed by a B, followed by ENDL. And then you have that same code. I mean, heck, let's make it actually work. Then you have the same code, but you put the plus plus in front of the A. The difference in the positioning of the increment operator tell you whether it happens at the beginning of that line, execution of that line, or at the end of the execution of that line. And y'all are used to the idea of game playing, you know, where you have a turn and you can do all these things. If the plus plus is in front of the variable, it happens at the beginning of the turn, before anything else happens. If the plus plus follows a variable, it happens after the end of the turn, after everything else happens. So if you traced it, here's what would happen. 10 gets copied into A. And then it would say B is equal to A plus plus. Well, the plus plus follows the A. That means it's going to happen at the end of the turn. So right now, A is equal to 10. That 10 gets copied into B. Then A is incremented. So what is it going to print? A is 11 and B is 10. Why? Because this increment here didn't happen until the line was done executing, because it followed the A. Now here is the opposite. A is 10, we come in here, 10, the plus plus means do that at the very beginning of everything. So 10 immediately turns into 11, and then that's copied into B. So when we print it out, A is equal to 11, and B is equal to 11. Hope that makes sense. If the plus plus precedes the name of the variable, it happens right away as soon as that line of code is entered. If the plus plus happens after the variable, it's the last thing that happens as the, after the semicolon is processed, essentially. So this means that A does not turn from 10 into 11 until after that line is already done. This means that the 10 turns into an 11 before the rest of the line is done. We good on that? Hope so. So, one way it's called a prefix. Prefix means it comes before, and after it is called a postfix. And we usually see it as postfix. In reality, you can usually mix and match them unless they're being used as part of a calculation, like here. You couldn't do that. You can't just mix and match them. They don't mean the same thing. But if you had it all on a line all by its lonesome, it wouldn't matter. If you had that on a line, or if you had that, they're going to do the same thing because there's nothing else happening in that same line. That is the entire turn. The turn ends and begins after that is executed. Minus minus, that's called decrement. If plus plus means increment, minus minus means decrement. It subtracts one from it. So V minus minus is the same as V equals V minus 1. You can also do it as prefix or postfix. If you do it as postfix, it's the last thing that happens in that line of code. So whatever else evaluation is going on happens first, and then it is decremented. Here's another example of that. If we go into our code and we do this, A is equal to 100, and then we do C out A plus plus. What do you think it's going to print out? You might think it's going to print out 101, but it doesn't. This prints out 100. Why? Because the plus plus doesn't happen until the line of code is executed, because it's postfix. But if you did this, B is equal to 100, C out B plus plus B and L. Does the plus plus come before or after the B? It comes before. It's prefix, which means it's the first thing that happens before the line of code executes. So that 100 turns into 101, and then it is printed. So the postfix version did it after it printed it, changed it to 101 after it printed it. The prefix version changed it to 101 before it was printed. While loops. We've already been using while loops. That means that this is not going to be overly complicated to talk about. A loop is a control structure that causes a statement to repeat, or a group of statements to repeat. The general format is while, and this expression repeats. It's either just one statement or it can be a block of statements. This expression can be something like x is greater than 100, while, t is not equal to true, while continue equals yes, or it can just be a value. It could be the value true. This is a valid loop. It's called an infinite loop. But if you did this, while true, print hello, that's good code. It'll run forever. That's not really good, is it? You don't want your program to run forever. But that's called an infinite loop. However, this syntax is useful for writing something that's going to keep repeating until the user chooses to exit. And I'll show you what I mean. We could do this. Cout type 1 for lots of fun, or 2 to quit. That's pretty vague. Now let's make a variable to hold that input. Let's CIN into that input variable. Now we can check, did they type 2? Did they want to quit? If input is equal to 2, we could put our return statement right there. Else we have fun, whatever that fun is. And so this would be in a function called main, of course. With all the pound sign includes up at the top, that it needs. But there we go. We've written a loop that runs over and over and over until they enter an input of 2. And we didn't even need to do while input not equals to 2 this way. We just said do it while true. The loop will keep repeating infinitely until they type a 2 and we hit a return. So whatever is in there can be an expression, or it could just be a single variable if it's a Boolean variable, or it could just be the word true. If it was the word false, it would never execute, because this code is like an if statement. It only goes in there if whatever's in there is true, or evaluates the true. So the expression is evaluated, and just like an if statement, this is conditional. It doesn't execute it if this expression is false. It does execute it if this condition is true. But unlike an if statement, it then comes and checks the expression again. And then it checks the expression again. And then it checks the expression again. And something had better change this expression, or there needs to be a return statement in it. And what do I mean by that? What if we had this code? Int I is equal to 0, while I is less than 10. Print I. What is that going to do?
Print 10 times?
It's what we wanted to do, but there's a big, big fat bug in it.
Well, you set I equal to 0.
We said I is equal to 10. Nothing ever increases it. So it's always going to be true, and we're going to print out a whole bunch of zeros. It's an infinite loop because nothing ever changes this. To make this code right, we have to increase I, like that. Then it would count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if nothing ever changes this value right here, then there better be a return statement somewhere in the code that'll break you out of it. Or a break statement, which we haven't talked about yet. Because if there's no way out of the code and nothing ever changes this, then it'll be an infinite loop. And I do that all the time when I'm demoing stuff for classes. I'm used to using something called a for loop. A for loop is much more convenient to write, and you don't have to type in I++ at the end of the for loop in order to get to increment. And then when I type in a while loop to show y'all, I leave this out. Now this time I left it out on purpose. So here they show the logic of a while loop. I disagree. I don't think it works like this. I would draw slightly differently. My while loops This is just a semantic difference or something. Fiddly difference. I actually put the word while here, and then after the statements, I draw the arrow coming in like that. No biggie. It just shows that it's going to loop. The reason I do that is this may be 100 statements long, you know, and then it's going to come back and hit the while loop again, and it's going to keep repeating over and over until this condition is no longer true. But can't argue with their PDF, their PowerPoint. That's as good a representation as any. Here's a while loop in a program. Number is equal to 1. While number is less than or equal to 5, print hello, and then add 1 to the number. So what is this going to do? Is number less than or equal to 5 the first time it gets here? Number is 1. Is number less than 5?
Yes.
Yep, so it's going to print hello. It adds 1 to number. Number is now equal to 2. Is 2 less than 5? Yep. It prints hello again. Adds 1 to number. Number is 3. Is 3 less than or equal to 5? Sure is. Prints hello once more. Is 4 less than or equal to 5? Yep, it prints hello another time. Is 5 less than or equal to 5? Yep, so it prints hello one last time, and now it's going to bail because number gets increased to 6. And 6 is no longer less than or equal to 5. And then prints that's all. So if we ran it, it would look like that. And here is how he would flowchart it, which I disagree. I'd put the word while right there to make sure it was incredibly obvious what we're doing. And I would line up all of our print statements vertically rather than horizontally like that. And then I would have the arrow come back there. But that's a stylistic difference. While is known as a pretest loop. Pretest means that the test happens before the code is executed. There's another kind of loop where the code gets executed before the condition is checked. That's called a do loop. But a while loop, the condition gets checked before you go into the code. So it's called pre-test. Pre meaning before. Watch out for infinite loops. The loop has to have something that will make the expression become false. Otherwise, the loop has no way of stopping. And it's called an infinite loop. The one exception to that is if you include a break or a return statement in the logic somehow to cause that loop to abort. As I showed here. Type 1 for lots of fun, type 2 to quit. If input is equal to 2, return. We had some way of getting out of the while loop because of that return statement. It exits the program. Otherwise, it would run forever. Or until the user killed it, more realistically. Sorry. Here we go. So an infinite loop is a loop in which the expression never becomes false. The expression being the thing between the parentheses. Example of an infinite loop. Number is equal to 1. While number is less than or equal to 5, print hello. Well, nothing ever changes the value of number, so it's going to print hello endlessly, infinitely. Using the while loop for input validation. When you're asking the user to type in something, sometimes you really care whether they got a good value or not. Like you want to force them to make a valid choice. If you say enter choices 1 through 4, you don't want them to enter 5. So input validation is the process of inspecting data that is given to the program as input and determining whether it is valid. So the while loop can be used to create input routines that reject invalid data and repeat until valid data is entered. So let's give an example of that. In our birthday program, I'm going to go back to main. And I want to ask them how many times to print happy birthday. So int times is equal to 0. See out how many birthdays. Cn into times. Then we need it to repeat that a certain number of times. Let's skip the logic that actually makes it print birthday 5 times But right now, we're just trying to validate it. What could be invalid input in this case? What if they type in -1? Is it possible for us to say birthday -1 times? No, we can't say birthday -1 times. So if they type in a negative value, that would be bad. That would be invalid input. So what we might do is put that in a while loop. I'm going to set times to an invalid value. I want them to enter a number larger than 1. We're going to say happy birthday at least 1 time. So I'm going to say while times is less than or equal, while times is less than 1. Then we ask for their birthday, we read in the number of times, and then we check it. If times is less than 1, then we're going to print an error message. Cout must be 1 or greater. Now this loop will not exit until they type in a number that's 1 or greater. So that's an input validation loop. And there's all sorts of ways to write input validation loops. And the book will have a different example, and later on I'll probably use a different example still. But that's the idea. You enter the loop, you ask them for the answer. If the answer is incorrect, it loops again and asks them for it. So I'm going to run it and make sure that it works. How many birthdays? I'm going to type in -1. It says must be 1 or greater. How many birthdays? 0. Must be 1 or greater. How many birthdays? 1. And then it goes ahead and does something. Now we didn't actually put any logic in to make it repeat the number of birthdays. We could do that as well, but this is the more important thing is how to do the input validation. And you can rejigger it different ways, based on the input. But like for our menu choices that said, press 1 for this, 2 for that, 3 for that, 4 for that. You may have to, change your while condition and your if condition a little bit. But hopefully you get the idea. You just keep looping, rejecting invalid input, and then when they finally type in valid input, then it's okay. We will revisit this idea. Is this working for everybody who was trying to get it to work?
This may be correct.
You just need one more close after that one.
Here.
Right there. Yep. Yeah, that should do it. So try with -1 and then 0. Are you playing along? Yeah, that's okay. Okay, did it work?
Yep.
Everybody good now? If not, let me know. All right, so that's using a while loop for input validation. I'm going to show you how I would write it. Not that I'm so special, but I would rewrite it like this. I would just put while true. And then like that. And then if this was valid, I would break. Else I would print the error message. About the same number. I mean, really, it's hardly any different. But you'll see me do this a lot. You'll see me start off a loop from now on with while true. We'll ask for some input, and if they type in something that we hate or that we want to exit from, you know, either the correct input or the incorrect input, depending on what the loop's supposed to be doing, then we will issue a break. A break is like a return, but it doesn't exit the code. It just exits the while loop. So when it sees this break statement, it's going to come down here, and then it's going to continue processing. So if the number of times that they type in is 1 or greater, it's a good value. So we're going to break, which skips to the end of that while loop, and then prints, you know, happy birthday, Joe. And you will see that again. The book doesn't show doing it that way. They show doing it slightly differently. It's called a priming read. A priming read is when you read input the first time, and then you check to see if it is invalid. If it's invalid, display an error message and read the input again. So here's the book way of doing it. You tell me whether you like this or not. Int times is equal to 0. See out how many birthdays. Then cin into our variable. If it's not valid, if times is less than or equal is less than 1, then we print an error message. No, let's make this a while statement. While times is less than 1, we print out an error. Must be 1 or greater. And then we do this again. We ask for the number of birthdays and we read it in. That's the book way of doing it. Maybe you think that looks hunky-dory, copacetic. I don't like it because we're doing the input in more than one place. This is duplicated code. That code is duplicated here and here. Functionally, it's the same. But what if we just change the language for how many birthdays? We change that, you know, Vietnamese. Then we forget to change it here. Well, then we ask them in the correct language, but then when we printed out our error message, we turned around and asked them in English. Yeah. That's a silly example, but it shows the problem. Whenever you duplicate code like that, it introduces a possibility for errors. And if the input routine was more sophisticated, more complicated, it couldn't just be done in 2 steps, you really wouldn't want to do it like that. So I don't know if you can visualize in your mind how that is different than the first way I showed you, but the way that I showed you to begin with only had the input happening in one place, not twice. We initialized this to a bad value, and then we did this inside of an if statement. Conditional if statement. So you have a choice. You either do the input twice, or you have an if statement in there that prints out an error message. You're going to have that level of complexity either in one place or the other. You know, on the right hand you have, you know, a copy and paste of the cout and the cin, and on the left hand you have the if statement. want to get those both up on the screen. I don't want to belabor this point, but I would like y'all from now on to try your hardest to not allow bad input. If the choices are 1, 2, or 3, don't let the user type in 4. And we showed some input handling routines for catching totally bad input, like if they typed in letters and rather than numbers. I'm not requiring that yet, but just be thinking along those lines of trying to make your program as perfect as possible, as bulletproof as possible. So that's one way of doing it, and then let's open up another editor. Don't we have Notepad++? Yeah. The other way we do it is we initialize times with an invalid value, and then we put this code, how many, right there inside the while loop. And then we check with an if statement. If times is less than 1, we print out our error message. Sorry, I need to turn word wrap off. It's just messing it all up. So print out the error message there, whatever the error message is. This is the prof-approved way of doing it. This is the other way of doing it. Pick one and stick with it. Counters. A counter is a variable that's incremented or decremented each time a loop repeats. Like that counter 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If it controls the execution of a loop, it's called a loop control variable. Rock. Okay.
Pokemon Go just came out.
And then you have to initialize the variable before entering the loop. So say we're going to have some kind of counter that's going to print hello 10 times. This is stupid, but okay, int I is equal to 10. And then we're going to do this while I is greater than 0. We're going to print hello, and then we're going to subtract 1 from I. This is our counter. Its values go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then when it finally hits 0, it breaks out of the while loop.
Does it matter in a step like that if you do minus minus I?
Nope. And the reason why that's okay is because it's the only thing on the line, so it doesn't matter whether it's happening at the quote beginning of the turn or the end of the turn. Here he's going to a lot of trouble to use constants to define the minimum value of a counter, the maximum value of a counter, to initialize a counter variable, and then to have a while loop that counts from the minimum to the maximum. So he's printing out the number and then the number squared. So constant, or you could use pound define. Define min as 10 or 1. Pound define max as 10. And then to create your variable, int number, you set it equal to your minimum. You have to initialize it to your starting point. And then you do while number or counter is less than max, less than or equal to max. Do whatever's important to you. In this case, I'm just going to print hello again. And then add 1 to that. Number plus plus or plus plus number. There you go. That's how the book is illustrating doing it. Rather than hard code the numbers into your initialization and your comparison statement, define them as constants or as pound defines in your program. If they're pound defines, they go above the main. If they're constants, they go inside the code. That's how to do it with pound defines, and then let's just repeat this. So int main. Or let's define them as constants. So repeat that code. Take the defines out and make them constant ints. Const int min is equal to 1. Const int max is equal to 10. Two ways to do that. Scroll them up so that we can compare them. Compare and contrast. One's using preprocessor to define minimax, one is using constants to define them. Is there a reason to prefer one over the other? I'm not coming up with a good reason. The do-while loop, and this will be the last thing we cover today. The do-while loop is a post-test loop. What it does is it executes the loop and then it checks. So I'm going to change my birthday code to have two different loops. Int a is equal to 10. And then while a is greater than 0, do something. Let's just print out a. A is equal to, followed by the value of a. And then let's subtract 1 from a. You can put the a in the beginning, the minus prefix or postfix. There we go. Either one works. Okay. This is a pretest loop. Now let's do the same thing, but we're going to make it a post-test loop. B is equal to 10. While B is greater than 0. No, do some code while B is greater than 0. Same thing, we're going to see out the value of B. And then we're going to subtract 1 from B. These are actually going to do the same thing. Well, then why did you type them both in? Because there is one circumstance when they do something different. Here we have A is equal to 10, and it counts all the way down to 1. Then it stops. The second loop starts. B counts down from 10 to 1. So what's the difference? Well, in this one, the condition is tested before it enters the loop. So if this is an invalid value, if this already was 0, it doesn't print anything for A. But in this one, it executes the body of the loop no matter what the value of B is. B could be a negative billion, and it would still do this at least once. And then it checks, oh, is B greater than 0? No, it's not, so don't repeat it. So now it's going to behave differently. This time it's not going to print any values of A, but it is going to print B is equal to 0. And the reason is because this is a post test. And it doesn't matter that B is equal to 0. It still performs this code first before doing the test. And then only after that test is done does it break the loop. Here the test is a pretest, so it does it before the loop condition, before the body of the loop. And if this is not true, then none of this happens. So since we set A equal to 0, since this condition is false, we're not going to even get any A messages. But since this is post-test, it's going to print this one time before it realizes that it's an invalid condition for the loop. Or it'll not run at all. That's always possible. Probably because I already had it open and I didn't close it. There we go. It said B is equal to 0. It didn't print A anything. And the reason is because this is post-test, not pre-test. So when do you use a post-test loop? You use a post-test loop if you want the body of the loop to execute at least one time, no matter what. You use a pre-test loop if you don't want it to execute if the condition is invalid. You do have to put a semicolon there. You don't put a semicolon anywhere else after a while. If you went up here and you put a semicolon after that while in the pretest loop, it would break the loop. And I think I've shown you why in the past. But here, if you don't put a semicolon after the while in a post-test loop, it doesn't work. So we'll just add that as a comment. Post-test, semicolon is required. So do you remember our while loop? It showed the condition, the diamond, and then it showed the statement. A do loop has a statement before the condition. So it always does a statement at least once, and then it checks to see if the condition is true. And if the condition is true, it repeats. So, notes about a do-while loop. The loop executes at least one time. Execution continues as long as the expression is true. Here's their editorial comment. Useful in menu-driven programs to bring the user back to a menu to make another choice. I don't see why it's any more useful than a while loop. All right. And then the big daddy loop, the one loop to rule them all and then the darkness bind them, is the for loop. And we'll save that for Monday. So, let's see if we had a homework assignment cooked up and ready for y'all. Alrighty. So, homework 7 shouldn't be too challenging, but give it a stab so that when you come in on Monday, if you've had trouble with it, we can talk about it.
Which files do you want?
Your 2 CPP files, birthday.cpp and main.cpp, and then that birthday.h. Or just zip up the whole thing like you have been doing. If you've been giving me zips, that's perfect.
How can you rate it?
If you're going to zip, then when you need to know the path to your program. Once you know the path to your program, you go out. Let me exit out of. It's always a good idea to not be in Visual Studio, to exit Visual Studio. Anyways, my files are in the Documents folder. So I go to Documents, Visual Studio, Projects. And then I right-click on the folder and I do Send to Compressed. That'll make a zip file. And then you upload that zip file. I'm just as happy getting the CPP files and the H file by themselves, but it's also pretty dang easy to make a zip file and upload them that way.